In this video, we're going to solve a limit algebraically, or in other words, analytically. And the limit that we're going to solve is the limit as x approaches -4 of the square root of 7 plus x minus root 3 over x plus 4. Now, this is a limit which has a radical binomial in the numerator, and so we're going to use conjugates in order to solve this. We're going to multiply by the conjugate of the numerator, but we're going to do that both in the numerator and the denominator. So in other words, like this. The limit as x approaches -4. In the numerator, we still have 7 plus x minus the square root of 3 all over x plus 4. And then we're going to multiply by the conjugate, which is the square root of 7 plus x plus root 3. And we're going to multiply by the same thing in the denominator. And the reason why we do that is whenever we divide a number by itself, the result is 1. So that means that radical 7 plus x plus radical 3 over radical 7 plus x plus radical 3, that thing is really 1. Now, we don't want to cancel it out here, but we're going to use it. So when we're multiplying 1 by the original limit, that doesn't change the value of the limit. It changes the form of the limit, but it doesn't change its value. So the next step is to actually do the multiplication. So we have the limit as x approaches -4. And when we multiply conjugates, what I'd like to bring back to your mind is that if we have something like a plus b multiplied by a minus b, that becomes a squared minus b squared. And perhaps you learned this back when you took Algebra 1. So what this means is that when we multiply two conjugates, we square the first number, and we square the second number, and we put a minus sign between those results. So in the numerator of this fraction, we're going to square the first number. So the square of the square root of 7 plus x is just 7 plus x. And then we're going to square the second number, which is 3. And so the square of the square root of 3 is 3. And we put a minus sign in between. Now in the denominator, we still have the x plus 4 there, but now we have the other part of, we have the conjugate, which is the square root of 7 plus x plus root 3. Okay, now we're going to do some simplification in the numerator. So we have the limit as x approaches -4. And in the numerator, we end up with x plus 4. And we write everything else down the way it was. Okay, so now hopefully you can see that we can cancel the x plus 4 both in the numerator and the denominator. And once those are gone, we get the limit as x approaches -4 of 1 over the square root of 7 plus x plus the square root of 3. And the way we can evaluate this is the original limit was, if we replaced all the x's with -4, we end up with an indeterminate result. We end up with 0 over 0, which is why we have to modify the form of this limit, not its value. So at this point, what we're going to do is evaluate the limit by substituting -4 in for x. And so we have this, and that simplifies to 1 over the square root of 3 plus the square root of 3. And then doing a little bit of algebra on this, this becomes 1 over 2 times the square root of 3 We can leave it like that, or we can go on and rationalize by multiplying by the square root of 3 over the square root of 3. And by the way, rationalization is what we did up here as well. Right? Multiplying by the conjugate with the roots like that is a form of rationalization. So we're rationalizing here as well by multiplying by 1 again, but the form of 1 is root 3 over root 3. And so if we multiply this out, we get the square root of 3 over, and the reason this works is because the square root of 3 times the square root of 3 is equal to 3. So that becomes the square root of 3 over 2 times 3. And so the final answer is the square root of 3 over 6. So we can leave it as this answer, or we could have left it as this answer. Hopefully you find that helpful. Now, moving on, we could have had this similar problem. We could have had it in this format. The limit as x approaches negative 4 of x plus 4 over the square root of 7 plus x minus the square root of 3. Right? We could have done this problem. And we're going to do it the same exact way. We're going to multiply by the conjugate. And you probably can see where this is going to go. So we multiply by the conjugate, rationalizing both in the numerator and the denominator. So in the numerator, we get x plus 4 multiplied by the conjugate. Oops, let me squeeze in a parenthesis there. Like that. And then remembering what we get when we multiply conjugates, the a plus b times a minus b equals a squared minus b squared. We square the first number, which gives us 7 plus x. And we square the second number, which gives us 3, put the minus sign in between. Then we do some simplification with the algebra. So we have x plus 4 times the square root of 7 plus x plus root 3 all over x plus 4. So once again, the x plus 4's cancel. So we have the limit as x approaches negative 4 of the square root of 7 plus x plus the square root of 3, and we'll put that in parentheses. Now we're going to replace the x by negative 4, and we get the square root of 7 plus negative 4, and then plus root 3. And this becomes the square root of 3 plus the square root of 3, and so our final answer is 2 root 3. So an interesting take on these problems where we have radicals and we have to use the conjugate concept here, conjugate factoring pattern, in order to solve the problem. Hopefully you found that helpful.